All right, so we're going to be looking at section 9.4, part 1. And what this whole section is about is called conics. Okay, so a conic is basically a different way you can slice a cone and look at the shape that you make. Does anybody have some ideas about the different shapes you can get when you slice a cone different ways? Yeah?
Trapezoid? Or not trapezoid, sorry, like a half pipe?
So we want to think two-dimensional shapes.
Triangle.
Where?
You can't get a triangle when you slice a cone.
Pyramid.
Half a card.
No, 2D shapes.
Circle.
What's that?
Circle?
A circle. How could you get a circle when you slice a cone?
Like that way.
Yep, take the cone and slice it straight across the top, and then look at the end, you'll have the circle. Okay. What's another one? No, you can't get anything that has nothing with a straight edge when you slice a cone. All the edges would be curved. Yep, you could get an oval, or we call it an ellipse. How could you get an ellipse when you slice a cone? Yeah? Yep, if you take a cone and you slice it on a diagonal, and you look at the shape you made, you're going to have an ellipse. So that's another one. The other two are a little harder to think of, but if you take a cone and you slice it straight down, not necessarily through the point of the cone, but like off to the side a little, straight down, in that case you get what's called a hyperbola, and you have to actually take two cones and put them end to end to make that work. So two cones end to end, sliced straight down, is a hyperbola. And then if you take a cone and you slice it on an angle, but you actually end up coming out the bottom, you know, not straight when you get a circle, not through the side when you get an ellipse, but through the bottom, then you have a parabola. Right, so those are the 4 different conic sections you can have. And a circle is really just a special case of an ellipse. You can use the same exact formulas for circles and ellipses, pretty much. Now, we're going to be studying conic sections in function notation. Okay. The next step after this would be to study them in polar or parametric. And for some things, it is easier to do conic sections in polar, but we're going to do everything as like y equals. So that means certain shapes, if we want to draw them on the calculator, like a circle, you can't really do it in function. You'd have to cheat and do it in 2 parts. So we might have to draw shapes in 2 parts. So any questions on those 4 shapes and how you can get them? All right. So the first thing we'll start off with each conic section is just describing what it is, okay, the definition. I'll give it 2 words, and then I'll show you an image that I think will help it make more sense. Let me start off with an easy one, like a circle. Okay, that's an easy one to describe, but we do circles with ellipses, and we're doing ellipses next time. So if we were talking about a circle, we'd say it's a collection of points that are all equidistant from one point. That's a circle. It's a collection of points that are all the same distance from a center point. Okay, that's another way to say it. Well, a parabola, it's a little bit more complicated definition. It's a collection of points in the plane, meaning it's 2-dimensional, so not 3D. So collection of points that are the same distance from 2 things. So if you measure the distance from the point to one thing and the point to another thing, it will always be the same. I need to tell you what those 2 things are. So it's a collection of points that are equidistant from a fixed point we're going to call F, which stands for the focus of the parabola, as they are from a fixed line we're going to call D, which stands for the directrix. So every point on a parabola, if you measure the distance to its focus and to its directrix, those two distances will come out exactly the same. All right, so now I'm going to show you a picture of what that looks like. Okay, so the idea here is we're going to measure the distance between two things, a point in the focus and a point in what's called the directrix. So here's an example of a parabola. There are 4 basic types of parabolas. Opening down, which this one is, opening up, opening left, and opening right. We'll look at all 4. A, I don't know why that's just the letter that this program used. A is what you call the focus. It's a point that the parabola wraps around. So the focus is always inside of your parabola. Line DE, that line up at the top, is called directrix. It's a line that the parabola always bends away from. The parabola never crosses the directrix. It bends away from it. Now, B is a point on the parabola that I can move. And as I move B, let me do it from here. As I move B, it's not supposed to be in half. So as I move B, the distance is being measured no matter where I put it. The distance from A to B is the distance between the point on the parabola and the focus, and the distance from B to C is the distance between the point and the directrix. You always have to measure the distance from the point to the directrix straight. You can't measure it like at an angle. You want to measure the shortest distance you can between this point and this line, which is perpendicular. So no matter where I can't drag it from here, but no matter where I drag it, if you watched, those two numbers always stayed the same. They didn't differ from each other at all. And that's the definition of a parabola. Any point on this curve is the same distance from point A as it is from this line up at the top. Okay. Any question on the definition? Okay. So conic sections generally have a few vocabulary words that go with them. So I already told you those two. So F, again, you wrote up there, is the focus. D is called your directrix. And if we go back and just look at the picture, what do you think if you measure the distance between this point right at the top of the parabola and the focus, and you measure the distance from that point to the directrix, how do you think they would compare?
Equal.
Yeah, they are equal. That's part of what we can use to solve problems. The distance between this point is always the same from here to the directrix and here to the focus. In fact, that's the definition of a parabola. This point at the top is just one special point. And we'll name what that point is in a second. But that distance is always equal. Right, so the distance between the focus and a point on the parabola is the same as the distance between a point and the directrix. This is writing out the definition as an equation. Now, if you draw a line through the focus and perpendicular to the directrix. Right, so here's your parabola. There's your directrix. If you draw a line through the focus, which might be like right in there somewhere, and perpendicular to the directrix, you get a line of symmetry. That red line is called an axis of symmetry. For a parabola that opens up or down, the axis of symmetry is always vertical. If the parabola opens left or right, then the axis of symmetry is horizontal. Now there's a special name for where the axis of symmetry and the parabola cross. Anyone remember what you call that point in a parabola? The vertex. Yep. Where the axis of symmetry crosses the parabola, that's the vertex. In a parabola, there is only one vertex. So you're not going to ever have to use the plural, which is vertices. When we talk about ellipses and hyperbolas, there'll be multiple there'll be vertices, plural, not just a vertex. And there's one other special distance that they do measure across the parabola, and the distance through the focus across the width of the parabola, the book calls that the lattice distance or lattice rectum distance. I don't know why, this is what they call it. So it's the width of the parabola specifically through the focus. Not something we're going to focus on a lot, but I'm just saying if you see the word lattice, then you know it's talking about the width of the parabola through the focus. Any question on that? Now, parabolas have kind of a special property, because where the focus is an idea. That's a thing that's used when people, when you get like a satellite dish. Right? You might see, a dish, and then usually inside the dish, you might see something like this. See, like a little thing right there. So the way that a parabola works is signals can bounce in from all different directions. But no matter how the signal bounces in, it always bounces off the wall, and it goes right to that point, always. So anything that bounces into the parabola is reflected right to that point. And then what happens there is usually some kind of wire, and then it goes down into your house, and that's it. So it kind of like focuses all the signal right to that point. So it's a parabolic. Satellite dishes are usually in a parabolic shape. Okay, is anyone in autotech? Automotive? Well, headlights kind of work the same way. It's the opposite though. Instead of signal coming into the headlight, you're sending signal out. And by signal, I mean light. So the idea is you've got a headlight, and you might have something like this, and here's the bulb, but sometimes there's like this little shield around it. So you're never actually looking at the bulb. You can't see it, it's hidden. And what happens is when the bulb lights up, this part right here, it's like a little mirror, and everything reflects off of it like this. So all the signal is coming from a light bulb, it's bouncing off the mirror in the headlight, and then it bounces the rays out perfectly straight. And that's why headlights generally don't shine up in the air, they shine pretty much forward. The beam may spread a little, especially if it's shining at something further down the road. But a lot of headlights are parabolic reflectors. All right, so let's take a look at the equation of a parabola. And there's going to be 4 different equations depending on if the parabola opens up, down, left, or right. So for the initial problems that we do, we're going to do an example where the vertex is at the origin. Okay, I'll show you how you shift it, but for now, just vertex at the origin. And we're going to do the one where the focus is on the positive x-axis. So Anybody think they could tell me which way the parabola is going to open? Your vertex is at the origin, and your focus is somewhere on the positive x-axis. With those 2 points known, it has to open a certain way. Yep. To the what?
Right.
Yeah, it's going to open to the right. It has to.
Good job.
The focus, the parabola has to wrap around the focus, and the vertex is at the origin. Now, if we know that, where would the directrix, or what kind of line would the directrix be? Horizontal or vertical? It would have to be a vertical line, and the distance would be equidistant to the focus. So your directrix would be over there. And the equation, I have something here. So the equation for the situation I just described is y squared equals 4ax. So this is the standard form of a parabola at the origin, opening to the right. Now, we want to be able to look at that equation and identify if it's opening up, down, left, or right. So I told you this one opens to the right. The way you can tell by looking at the equation which way it opens, there's a few ways you can tell. But you look at the variable that's here, and you look at the number that's there. If this is a positive number, it's always going to be a 4, but it could be a positive or it could be a negative. If it's a positive, it's either going to open right or up. Those are the two positive directions. If it's a negative, this 4 tells me it could open left or down. Okay, left or down, those are the negative directions. Now, to narrow it down from there, you look at the letter that's here. If it's an X, X means it always opens left or right. It opens along the x-axis. So here's an x-axis. This basically is telling you what the line of symmetry is, the x-axis. If you had a y here, okay, your equation would look more like this. The 4 tells me it's going to open up or down, and the y tells me what axis is going to cut right through the middle of it. So in this case, this would be a parabola opening up. Up because that's a positive 4, and that's a y. If you make that a negative 4, then it would look like this. If you make this letter an X and you keep this positive, it would look like this. And if you make this negative and you make that an X, then it would look like this. So those are basically the 4 different types of parabolas that we're looking at. So check the number, and then check the letter. Okay, but for now, we'll just focus on y squared equals 4ax. Then we'll try some other ones. So how do you want to graph a parabola? Well, you generally want to find the focus and the vertex and the directrix. These all give you hints at what it looks like. The only actual point, the only thing here that's an actual point on the parabola is the vertex. The focus is an imaginary point inside it, and the directrix is an imaginary line like behind it that it bends away from. After we find those, if we can find some points either to the left and the right of the focus or above and below the focus, that'll give us a good idea of what it looks like. And I say above, below, or left, right, because it depends which way the parabola opens. If your parabola opens this way, then you're going to want to find the vertex. You'll find your focus. And then I would find a point to the left and the right. Between those 3 points, you can make a decent sketch. If the parabola opened left or right, then I would say, well, find your vertex, find your focus, here's your parabola, then get a point above and below. So depending on which way it opens, you'll either go above and below or you'll go left and right. All right. Questions on that idea? So there's a few different types of problems I can give you with conics. One type is I give you some information about a parabola and you tell me the equation. Another type is we reverse it. I tell you an equation and then you tell me all about the parabola. From an equation, describe the vertex, describe the focus, describe the directrix. Or the third way is I give you an image on a grid so you can actually see things. And from that image, you tell me the equation. Right? So we'll try a couple of each type. All right, so here's the first one. Find an equation of a parabola that goes through the vertex at the origin, and the focus is 3, 0. Now, on the test, I'm not going to tell you which equation to use. The first step is to just figure out which way it opens, because that's going to tell you, is it y squared equals 4ax? Is it y squared equals negative 4ax? Which one do you use? So look at the two pieces of information I gave you. Vertex is at the origin. Focus is at 3, 0. Which way does this parabola have to open?
Right.
It has to open right. When something opens right, is that a positive 4 or a negative 4? Positive. It's opening in the positive direction. Opening right or up is a positive. So it's a positive 4. This is an A. And now, which axis cuts right through the middle of the parabola? And that goes here. What goes on the other side is the other variable squared. That's what makes something a parabola. One variable is squared. One variable is linear. Okay. When they're both squared, well, that's a different shape. We'll talk about that next time. Okay, so there's the formula we have to use. And now we have to figure out the equation. So the only thing that you have to figure out here is A. We just have to figure out what that one number is. And A, I'm sure if I wrote it down. Okay, well, we're going to write it down right now. So A is the distance between the vertex and the focus. And there's other ways to say that. You could say A is the distance between the vertex and the directrix. That's exactly the same thing. So, look at this problem. And what is the distance between the vertex and the focus? 3. So you're going to fill in 3 for A, and that's your answer. So y squared equals 4 times 3x. I'll just write it like that, so if you're watching it, you know where the 12 is about to come from. And the final answer is y squared equals 12x. If I was writing the answer, I would probably leave it just like that. But what if you wanted to put that in on a calculator? What would you have to do to both sides? You would have to square root. So you should know how to manipulate that and rearrange it for different variables. So you could do this. All right, because if it's a multiple choice question on a test, and you get what's in the box as an answer, and you see what I wrote below as a multiple choice, well, they're the same thing. So you do have to know how to rearrange it. All right, so now let's graph it. So we've got our vertex. We've got our focus. Can somebody give me an x value? I mean, you can technically pick all kinds of x values. But I'd like to pick an x value where I can do the answer in my head. What would be a good x value to plug into this formula that makes it easy to do it?
3.
What is it? 3? Yeah, if you plug in 3, 12 times 3 is 36. And what's the square root of 36?
6.
And
-6.
All right, so we get 3, comma, 1, 2, 3, 4, 5, 6. And we get 3, comma, 1, 2, 3, 4, 5, -6. There you go. So there's your vertex. There's a couple points. This distance right here, this is the lattice distance. If you ever asked for it, it's 12. It's basically double A. It's 2A all the time. And just get your parabola. So kind of like that. Any questions on how you would type this in on the calculator? Yep.
I didn't know about that, but you said that the distance from the 2 points are double A, but wasn't A?
Oh, I'm sorry, not double A. Yeah, you're right. It's no, it wouldn't be double A. In this case, it would be 4 times A. But I don't know if that's always true. I don't think so.
Okay.
But yes, you're right. No, it's not double A. I'm sorry. The distance between the focus and the directrix is always double A. That's what's to it. Because your directrix would be, did they ask for it in this problem? No. Well, where would the directrix, can somebody give me the equation of the directrix? Because I might ask for that. Is it horizontal or vertical? Vertical. So how does a vertical line equation start?
X equals -3.
X equals -3. So here is your directrix. And the distance between the directrix and the focus is always 2A. Okay. All right. Questions on that? Okay. Let's try this one. Discuss. When you see a question about a conic and it says discuss, that means I want you to describe everything that's important about that conic section. For a parabola, I'd be looking for you to tell me the vertex, the focus, the directrix, and which way it opens. I would say those are the four key things you have to tell me. Now the first step to be able to do that is to rewrite it in the standard format. This is not the standard format that we're used to seeing it in. If you write it like that, it's kind of like writing it like this. It's been simplified, but you want to take it back to what it was before you multiplied it. So when we write the equation, what number is always right here, and it makes A very easy to see.
4.
You always have to put a 4 here, then you put A here, and then you put X here. So right now we're basically figuring out A. 2. So A equals 2. And that should tell you pretty much everything. All right, so where's the vertex in this case? 0, 0. I told you when it's y squared equals 4ax, you're always at the origin for the vertex. You'll know when you're not at the origin. The equation looks a little different. It has a plus and a minus in it, depending on which way you shift. So the vertex is at the origin. Now, I think the next best thing is let's figure out which way it opens. Because if you can figure that out, it's going to make other things easier. The 4 is positive, and the letter is an X. So which way does it open?
Right.
It opens right. Right because it's a positive 4, and it goes through the x-axis. So it opens right. So now, think about it like this. You've got your vertex. How many units away from the vertex is the focus? It's 2 units away, and because you know which way it opens, you know which way, you know what 2 units, which direction to go. So the focus is going to be 2 units to the what of the origin?
Right.
To the right. If you didn't know which way it opens, you wouldn't be able to figure that out. So what's the coordinate when you go 2 units right of the origin?
2, 0.
2, 0. And now you've got that. Imagine your directrix. What letter does it start with? X, because it's vertical. And what number?
-2.
-2. Right. So those would be all the important things to describe about the problem. Questions on that? All right. Let's try this one. X squared equals negative 12y. And I put opens right away because I like to do that first. All right. Because this is a negative, it's either going to open which way or which way. It's either going to be left or down. But the y-axis is going to cut right through the parabola. So which way does it have to open? It has to open down. This is the axis that cuts through it, and it's opening down. So it's like the negative and the y tell you. So it opens down. Now let's rewrite that equation so we can see it and figure out a. It should be x squared, and then what number is always right here? 4, or in this case, it's a negative 4. The negative is never with the a. It's always with the 4, or the negative 4. So that goes there, because a is a distance. So that's 3. So how many units is the focus away from the vertex? It's 3, and it's 3 which way? Down. 1, 2, 3. There's your focus. What's the coordinate when you go 3 down? 0, negative 3. All right, vertex, that's the origin. That's technically the next thing you should figure out after you know which way it opens. But since we know it's the origin in every problem for now, we don't have to worry too much about that. Directrix. What letter is the equation going to start with? Y. It's horizontal. If you make the directrix vertical, your parabola is going to cut through it. You don't want that. So it's y equals 3, because it has to be 3 units away. It has to be symmetric with the focus in terms of the distance. So there's all your information. Any question on that? All right, so now we're going to come up with the equation. Find an equation of a parabola with the focus 0, negative 4, and the directrix at negative 4. Y equals negative 4. Now, technically, you can't assume the vertex is at the origin, but you have enough information there to figure out where the vertex is. Where is the vertex in relation to these two things?
Middle.
In the middle.
Always right in the middle of them. So what coordinate is exactly between y equals negative 4, there's your directrix, and the point 0, 4.
0, 0.
0, 0 is right in the middle. Even if they didn't tell you that, which they don't, you can figure it out. All right, so the vertex is 0, 0. I'm just going to write that off to the side because I'm trying to figure out which way it opens so I can get the type of equation that I need. Which way does this parabola have to open? It has to open up. So that means 4 or negative 4. You're going to have a 4. Right? We're going to have to fill in A. Well, I think we have enough information. What's A? It's the distance between the vertex and the focus. 1, 2, 3, 4. So A is 4. And if it opens up, what axis cuts the parabola in half? Y, which means over here you put
X squared.
x squared. And we should simplify that to x squared equals 16y. Now, if you were going to graph this on the calculator, what would you do to both sides? What letter are you trying to get by itself when you graph it? Y. You divide by 16. So this is a perfectly acceptable answer. And in fact, I might write the answer that way on the test. But if you start by doing it this way, I think if you just think about that first, then you can rearrange it any way you want after that. Don't try to think about this right away. Okay, you really want to think about it with the 4 and do it that way first. Okay, questions on that? All right. find an equation that has this as the vertex, the axis of symmetry is the x-axis, and the parabola goes through this point. Okay? Or axis of symmetry is the x-axis. So which way does that mean the parabola would have to open? Like, well, we have two choices if the axis of symmetry is the x-axis. It has to either open facing left or facing right. Now, it has to also go through the point -1/2, 2. So which way would it have to open? It has to open left. There's no way that it can open right and go through that point. It has to open left. So now let's get the equation that opens left. 4 or -4?
Negative.
-4 times a, which we don't know that yet. We don't have enough information to find that by looking at it. We can do something in a second. So -4, and which axis cuts through the middle? The x, and then what goes over here? Y squared. So now we need to figure out a. Well, what haven't I used yet in this problem? I haven't used that -1/2, 2. What can I do with that to find a? Plug it in. This is x, this is y. You're going to solve for a this time by plugging in a point, because you don't know the focus and you don't know the directive, so you can't measure the distance like we have all once before. So fill it in and watch what happens. 2 squared equals -4a times -1/2. All right, 2 squared is how much? 4. And a negative times a negative is a positive. And what's half of 4? 2a. So what's a? 2. So now go back, fill that in. Don't plug in for the x and the y. Just fill in the a and write the final answer. So what's my final answer here? -8x. Okay, so a little different because we had to find a in a different way. But once you get the idea of how to do this, it's all kind of the same. Questions on that? Okay. So now we want to take a look at what happens if the vertex is shifted. Okay, if it's not at the origin. Well, everything I've shown you so far still applies. If the number in front is a +4, and the letter over here is an x, it's going to open right. If this is a -4, and the letter is an x, it opens left. +4 and a y means up. -4 and a y means down. So that stuff is all the same. The only thing that's different is you either add or subtract something to the x and the y. And if you add or subtract something to the x and the y value, that shifts it, either up, down, left, or right. So what these two things are that you're adding and subtracting are h and k. HK is going to be the letters we use to represent the coordinates of the vertex. Up until now, you can think of the h and the k of always being 0. So if you just have y -0 and x -0, you really just have y and x. But now, the h and the k values might be something different. And the way I've been getting you to think about the parabola, you don't even really have to remember all these formulas. You can just look at the picture and you really can figure it out from that. What you do have to remember is the basic equation. If it's a positive or a -4, is it the x or the y that goes on the right? And then that determines if the x or the y goes on the left. And the h value is in the first part of the coordinate, and the k value is in the second. That means since h is in the first part, h is always the number that gets paired with the x. K is in the second part of the coordinate. That's the value that always gets paired with the y. If you switch them, you could shift your parabola up to instead of right to. It makes a difference. So you have to put the h value with x and the k value with y. I think I already told you guys this. So a is still the distance from the vertex to the focus. Okay, and the vertex will now be at hk. Right, so let's try an example. So we've got the vertex, we've got the focus. What I like to do, make a little sketch. Doesn't have to be perfect because they're not actually asking you to sketch. I just want to figure out which way it opens. My vertex is left 2, up 3. There's my vertex. My focus is up 3. Which way does this parabola have to open?
Right.
It has to open right. So let's set up the equation like the format, step by step. It's going to open right. Is that a positive 4 or a negative 4?
Positive.
Positive 4. All right. And now you still have the A. I know you might be able to figure that out right now. Let's hold off. But you still have the A. And now, what direction cuts through, imagine like a line like this? Is that the X or the Y?
X.
It's the X. Now, what variable is going to go on the other side?
Y squared.
That's going to be the Y. And you're going to square it. But now, what you put next to the X and the Y is an adjustment for where the vertex is. This is H. This is K. It's in alphabetical order. H before K. So we have a minus 2. That's going to go with the X. Now, you still have to be careful when it's a minus. So the standard format, let's write it like this, is minus and minus. The H value goes here, and the K value goes here. What is the H value in this problem? -2. So this is what you really have. It's always a minus, and then you put the number after it. What's the K value? 3. So the only thing I can do with this is just make that a positive because it was minus a minus. And that's it. That's your equation for a parabola that has a vertex at -2, 3, and a focus at 0, 3. Oh, we need A, I'm sorry, yeah. We can figure out the A value. What's the distance between the vertex and the focus? 2. Yeah, so I should put the 2 in there. So it's y minus 3 squared. You don't do that out. And what number is in front of the parentheses? 8. And you don't do that out. So you do have to find A. Any question on that? All right. So in general, I think I mentioned this already, parabolas, the equations always involve 2 variables. One of the variables is squared, and the other one is linear. Now, if I asked you to discuss this equation, especially when it's written as 4 times 2, you should be able to figure out how this equation was created, right? You could say, all right, well, I know that the vertex is hk, so let's just make one up. Y plus 3 equals 12, x minus 2. Okay, which way would this open? And if you're not sure, think of it like this first. What number would be in the first parenthesis? 4, and in the second one? 3. Okay. So which way does this open? Positive 4 along the x means it opens right. My vertex. Remember, the format of the vertex is h, comma, k. And h and k are always the number that comes after the minus sign. So you've got to be a little careful with this plus 3. What you probably want to do is think of it like this. Think of it as minus a minus. So, what is my h value in this problem? 2. It's the number that comes after the minus sign. Just the number after the minus. So h is 2. And what's my k value? -3. So we know the vertex. We know which way it opens. The focus, well, we can figure that out. The focus is, first of all, how many units away from the vertex? 3. This is your A value. That tells you that the focus is 3 units away from the vertex, and the parabola opens to the right. So think about, if you're more visual, think about it as a picture. Your vertex is 2, -3. Here's your vertex. The parabola is going to open to the right. Where is the focus going to be in relation to the vertex? It's going to be to the right of it. It's going to be inside 3 units. So, if you shift this coordinate 3 units to the right, what would it be?
2, 0.
5, -3.
Oh, yeah, that makes sense. Wow.
Plus 3 to that. So it'd be over here.
Wow.
5, -3. All right, so that's working backwards from an equation to figure out those numbers. Any question on that? The problem would be, what if you had an equation like that? It's like somebody took this problem and they actually FOILed this out and got y² plus 6y plus 9. And then they multiplied this out and got 12x minus 24. And then they put all the like terms on one side. Ugh, not good. You don't want that done out if you're trying to describe a parabola. So, if that has been done out, like somebody squared it, FOILed it, you have to fix the foiling. You have to bring it back to what it was before they foiled it. And that's what we'll take a look at in this last one.
I don't know if it's squared.
Yep. So yeah, something we've done a long time ago. So sometimes you need to complete the square to be able to discuss it. Okay. Not good. Somebody has taken it, foiled it all out, and really messed it up. So the first thing you want to do is at least put your variables on different sides. We usually keep the squared one on the left. That's how we've been doing it. And we put the one that's not squared on the right. So how would I move the -4y to the other side? Add. Okay. Now, there is only one term in a parabola that's squared. So you don't complete the square for the y value in this problem. The y value is not squared. You complete the square for the x value. So remember, the way we complete the square is we check that this has a coefficient of 1, and it already does. So that's good. And then you add something on both sides, and it has to do with this number. Does anyone remember the 2 things you do to that number? Two arithmetic operations.
You like divide,
Take the half.
Take half of it, yep, and
Multiply.
Square it?
square it. So the 2 steps to complete the square are take half of this number and square it, and add that to both sides. So in this case, what's half of this?
2.
And then square it,
4.
4, just a coincidence, it came out the same. and everything's still fine because you added the same number on both sides, but now this should factor extremely close. How does x squared plus 4x plus 4 factor?
X plus 2.
X plus 2 times x plus 2. Now I can see the horizontal shift. Again, you're probably going to want to think of it this way when we get to it. Minus a minus. That's fine. And what can I do on the right-hand side? Factor. Factor out the 4. And now, magically, I can see the vertical shift. And that's it. Now I've rewritten it in a way I can see what's going on.
Is there going to be a problem like this on the test?
I'll complete the square. There could be.
That's an April Fool's, right?
I don't think so.
Dang.
So you do have to know how to complete the square. Probably won't give you one where the coefficient here is something other than a 1. It's not much harder, but it would be one more step. But that would be about the difficulty you could expect. Yeah?
So in this case, it just means the A is 1.
Yeah, if you want to think of it that way, it's like x plus 2 squared equals 4 times a times y plus 1. All right, so we've got a positive 4, and we've got the y. Which way does it open? Up. All right, now vertex. H, comma, K.
2, 1.
Negative.
So let's write this in an easier way to think about it. So my H value comes from here, and what is it? Yep. And my K value? Negative 1. Now my focus. Well, the parabola opens up. Your vertex is at negative 2, negative 1. And it opens up. So how far away is the focus?
Negative 2, 0.
Well, yeah, so how far away is it?
1 unit.
1 unit away, and it's above it. So if you shift this up 1, you get negative 2, 0. Is our focus. Directrix, x equals or y equals?
X equals y.
Well, x equals would be vertical.
Y.
So we want a y equals. Now, we just have to figure it out. So the distance between, let me mark my focus, negative 2, 0. Okay. What's the distance between the focus and the vertex?
1.
So the distance between that and the directrix is also 1. So your directrix is down here. Where is that line at? Negative 2. That's negative 1. That was negative 2. So y equals negative 2. So if you want, you can print the table out and you could put that on your reference sheet. I don't know if it's going to be more or less confusing to use that table, because I didn't really use it as I was teaching you, because I just taught you what to look for, like positive 4. If you want to put that table on, you can. That's up to you. But this is what we just did in those last 2 problems.
Where can we find that?
It's in the book,
Oh, okay.
so it's online. So if you check, it's not going to be in the PDF for the homework, but it will be in the PDF for the chapter. And what I'm going to do is, you know what? I can go back. Let me put it on the screen again, and let me make it nice. So if you can't find it in the book, it'll be in the YouTube video. So you could just screenshot it from that or take a picture of it, however you want to do it. Okay, so I'll at least make sure it's in the YouTube video.
Oh,
All right, so that's the homework for tonight. I think 11 to 18 is all matching, so there's a lot of matching. Let me